Hello, I'm Iradukunda Godanse, and I'm going to present about statistical machine learning assignment. Starting from the exercise one, I have seen, after loading the data, I have seen that my data set has 225 rows and two columns. So after creating a scatter plot, I have seen that there is no linear relationship between our dependent variable and independent variable, since I can't pass a straight line between my points. So since our dependent variable is continuous, so this task is a regression task. So our function space is just a linear combination of our beta times our independent variables. Uh, So our loss function is just the mean square error, and the theoretical risk is the expected value of the loss function. So our bias learning machine is the expected value of the dependent variable given the independent variables. So by deriving the OLS estimator, we have seen that we first minimize the residual sum of square with respect to beta hat, and after that, we assume that the X transpose X is invertible, and we see that the beta hat is this. By commenting on the properties of F hat, we have seen that it's unbiased, means the expected value of beta hat is equal to beta, and it is best linear unbiased estimator among unbiased estimators since it has minimum variance. So by using V4 cross validation, we have seen that the degree 10 is the optimal degree, as you have seen also on this plot. Yeah. So by doing model comparison, I set the simplest one to have 1 degree, the optimal 10, and the complex one 20. We have seen that I have seen that on this graph that the simplest model is just a straight line. Doesn't well fit with the data. And the complex one and the optimal one, we can see that they are almost the same and they fit well with the data. But the optimal one is still the best one. So by fitting the box plot, we can see that the simple model it has the higher noises compared to the complex one and the optimal one. And the optimal one has the smaller error compared to both complex and the simple one. It means that the optimal one is good for this regression problem. By doing ANOVA, we have seen that the p-value is less than our level of significance, means that we reject null hypothesis, and we conclude that the our model is statistically significant. So as you can see also on the confidence interval. Coming to the exercise 2, we have seen that this is a classification problem since our dependent variable is binary, and we have seen that after plotting the distribution of a response variable, we can see that it's an imbalance problem. So we have large number of non-spam and the smaller number of spam. So it's imbalance and it's no good. So yeah, it's imbalanced because we have the larger number of non-spam email and smaller number of spam emails. So by fitting LOC curve on the same grid, we have seen that the RDA, QDA, and FRDA, they just have the true positive rate of 0.95, while naive bias have AUC of 0.88. Means that the RDA, QDA, and FRDA, they are more accurate than the naive bias. So Uh-huh. By fitting the box plot, we have seen that the RDA, it contains minimum errors. So is the RDA is the best machine on this problem, while the FRD is the worst machine for this machine learning. So thank you.